Hi, I am here today to show you and simulate with you DNA replication. Remember, this is a process that happens in S phase and our cells do it to copy our chromosomes. So let's take a look at my kit down here. I have a piece of DNA, which I've laid out flat. Remember that DNA is anti-parallel, so we're starting with a sugar on this end. This will be the 3' end, and this is our phosphate group in purple here, so that is your 5' end. And then the opposite down here, so then we start with our 5' and we end with our 3'. Now remember, there are 5 enzymes to DNA replication, and so the first enzyme is called helicase, and helicase comes along and basically unzips our DNA strand, and so these particular pieces are representing hydrogen bonds. So helicase is essentially going to unzip our 2 sides of DNA, something like this, right, and pull apart those sort of sides. Now our second enzyme will be primase, and primase is going to add a RNA primer. I have my primer already set. If this is the 3' end, then primase and DNA polymerase 3 and 1 can only work from the 5' end of the newly built strand to the 3' end. So I'm going to add my primer. If you will notice, my primer has uracil in purple here, and it has a different sugar down here, which is ribose. Once the primer is on, DNA polymerase 3 can bind. It can't bind to a single strand, so this enables it to be able to bind. And so now we can hop on and we can add the rest of our strand. So DNA polymerase 3 will hop on and start to build the rest of the strand. So it will complementary. Anytime you have a C, it will add a G. Anytime you have a G, it will add a C, and so forth and so on. So we have this particular strand copied like so. DNA polymerase 3, once it sort of goes its whole continuous way, then it will stop. Eventually it will fall off or join other kind of bubbles in the cell. Yeah. All right, so now we have DNA polymerase 3 that is copying down our strand, but we have this section of RNA primer that we cannot leave. So DNA polymerase 1 is going to come along and cut out the primer like so, and switch it with a DNA strand, right? That is equal in language. Now we have all DNA, but look, we're not hooked up completely. So our last enzyme comes in, ligase, and binds these pieces together. Now, you might have noticed that I've only done and copied the top strand. The top strand that is copied from 5' end to 3' end is continuous. The DNA polymerases can just go for it, right, until they reach the end of their section, and then they will fall off. However, this strand doesn't get to copy that way. Because we can only copy in the 5' to 3' direction, this strand has to wait for helicase to open up the strand, and then it will bind and copy in the opposite direction. This means that this strand is copied in fragments. This strand is called the lagging strand because it is copied in the opposite direction of the leading strand. This leading strand is continuous, and this one has to wait for helicase, so we say that it is discontinuously copied. That's all for DNA replication. I hope you've enjoyed this video. See you next time.